Hey friends, and welcome to my session about how to enable searching the easy way for your website. My name is Costas Pantos. I'm a cloud solution architect for Microsoft, and you're probably going to see me doing this a lot because it's really painful in my ears. But anyway.
You can use also this mic if you want.
No, it's all right. I want to move around, so.
Okay. So you will bear the pain.
Yeah, I like it. So let's start really quick because I have a lot to show you and a lot of code, so I'm not sure how I'm going to fit everything in 40 minutes. This is the topics that we're going to discuss. We'll have a brief introduction about the solution that I'm going to talk about today. We're going to talk about managing and scaling your service. We're going to talk about indexing, advanced searching features, scoring your results, and finally we're going to talk about multi-language. I guess we're all interested about that one because we're using Greek. So we're going to briefly touch that one too. So, disclaimer, I'm really on pressure here, so if you've got any questions or if I've skipped something that you'd like to ask, you can find me afterwards outside and I'll go over any question you have. And another disclaimer, if you're downloading videos or YouTube, please stop now. Everything I'm doing is using the internet because it's a service, so please respect the internet. So what is Azure Search? Azure Search is a search as a service solution that allows developers to incorporate great search experiences into applications. So what does search as a service means? It means that you don't have to install, configure, or do anything like that. You just click a few buttons and you have a service that you can use to put search into your websites. And we're going to see how that works. So I've got these gifts here, and I'm going to give them away for all of you that participates in answering questions. And they really do work, although they're Microsoft. You'll not see any blue screens or anything like that. So here it goes. What constitutes a great search experience? Come on, don't be shy. We've got only 40 minutes, yes. Yeah? So I'm not going to throw that away, because if it fails to someone, it's probably going to hurt him a lot. But at the end, you can come grab one of those. Yes, it has to be fast. What else? Yep. Yeah, ranking, exactly. We need to have some sort of way to manage the ranking in our system. Yeah, you can grab one of these as well. And I keep a couple of those at the end. So let's go over a few more features that constitute a great search experience. And you can test this yourself. That's the site that you can use. It's a demo site that Microsoft has created using Azure Search. It's a retailer website that sells bicycles. So we need to have some sort of type ahead, right? We need to search and some results appearing after we've typed to help the user decide on the search that they want to execute. We also need something called facets. You probably have seen that if you've shopped in any commercial site where you can select a category and filter on that category and see results related to that category, right? We also need heat highlighting. We need to know where our search term appears in the results. We need spelling mistakes. Whatever we type, we need to find the correct result in our search results. And we need geospatial search results. So we need to find out results that relates to the location that we are. So these are some of the features, of course, paging and sorting, right? And scoring, as mentioned earlier. And all of that pretty fast. We don't want to be delaying the user experience to our users. So these are some of the features that an advanced search scenario would enable. So these are all offered by Microsoft Azure Search. Now, there are other solutions that you can use, and there are solutions that are manually managed, and you probably heard some of those, like Apache Solar or Elasticsearch, and some that are used as a service, search as a service. We've got our solution, which is Azure Search, and there is a competitive solution from Amazon, which was pretty left out for quite some time. They are picking up right now. And Google App Engine that doesn't invest in search heavily right now, but there are other competitors out there that offer solutions as a service. You get the difference, right? The one on the left side, you have to manage, you have to set up, you have to cluster, you have to make it highly available. The one on the right is just there, you just click a button, and all of that you get for a premium, of course. Okay, what's the process of searching? We have a workflow, right? So first, in all the services that we've seen, we have to provision the service. Second, we have to create an index. And we'll talk about what an index is. Then we have to put data on that index. And then we'll be able to search those indexes. And of course, then finally tune the results, like put scoring and weights on the fields that we're most interested into. So what's creating a search service looks like in Azure? All you have to do is go to the portal and hit the create button, specify a few details. We'll go over those in a moment. And that's it, pretty much it. All you have to do is create a service. And what's more important, there is a free offering. So if you want to start trying it, working with it, testing it, see how that works, you can go ahead. You have your vouchers in your bags, your $100 vouchers in the bags. You won't be spending those $100 for search because it's free, but you can try it. Scaling is pretty easy too. All you have to do is scale those sliders up and down as much as you want. Of course, that affects the pricing, as you can imagine. So you'll have to go over the free tier into a basic tier and start paying for it. I won't go into the pricing and how much data you can put in, how many documents and stuff like that, because I wanted my presentation to be technical. So I'll skip that and just go to the portal directly. I hope you can see it. That's the Azure portal. That's what you'll see once you've activated your account. And to start a search service, all you have to do is click New and type search in the search box. And the first result that comes up is search. So I want to create a new Azure search service. Create. And I have to give it a name, which will become a URL endpoint. I have to give it the subscription, a resource group, which is something that groups resources together, and the pricing tier, which I've talked about. There's a free, basic, and standard tiers. And that's all that you have to do. And select the location, of course. There are data centers all over the world that you can host that service. So it depends on where you are and where you're serving your customers from. You click create, and in a few minutes, you have a service that you can use. I won't click create, I've already created for us. So I'll go to my desktop, and here it is. That's what you'll see once you've created your service. You have a few options here, and the most important one is the keys, because that's the username and passwords, let's say, that we're going to use from our code in order to interact with our service. So, okay, we've seen the first step of provisioning our service. I'm going to return to my slides and go to the creating an index part. So, okay, we've created our service, and now we need to create our index. How can we do that? First of all, what's a search index? You can think of an index as a table in relational database. You put documents into the index that you can search. An index consists of fields, and each field has some attributes: searchable, filterable, and so forth. So that's an index. So let's see how. No, let's move on, and we'll go create some index later on. So how can we index our data? We can use two methods. We can either push our data to our index, or use something called an indexer, which automatically populates our index from a data source. So two methods. There are plenty of ways, programming ways of doing those two methods. You can even use REST APIs to push data on your index, or upload data, create indexes and stuff like that. And we're going to see that right now. The indexers part allow you to perform a one-time copy of the data and populate indexes, or sync changes and invoke on-demand updates to those indexes. A very popular GitHub project is one that allows you to take advantage of a SQL Server feature called change tracking to update your indexes in a near real-time time frame. So pretty useful. So let's see now how we can. We've seen that how we can provision our service. Let's see how we can create an index. And for that, I'm going to use a tool called Postman. You probably know it. It allows me to create, to make REST requests. So I've created those 3 requests. The first one is the one that creates the index. And let me zoom in so that you can see clearly. The first part is the URL endpoint of my service. Then we have /indexes, and then the name of the index that I want to create, which is called Rails. And I have to use a couple of headers, as you can imagine. The first one is the API key, and the second one is the content type for the response. So if I send that, okay, I've got the response back saying that my index was created, the fields and the attributes of those fields was returned. And if I go back to my service here, I should probably refresh that, although it would appear after a few seconds. But let's go back and continue on with uploading some data. Now, to upload some data, I'm sending a post request to the service. The URL is the same: service endpoint /indexes /trails /docs, because I'm uploading documents. It's a post request, so I have a body with all the documents, and it's a JSON document. And what's really interesting is the action part. So I'm saying now upload. I could say update or delete or something like that. There are a bunch of actions I can use. And then I've got the fields. So if I send that, that's all it takes to upload a bunch of documents to my index. It was successfully executed. As you can see, I've got a 200 response back, and that's the result. Okay, the status and so forth, if I've got an error. So if I go back to my portal, you can see that I now have an index. I can see how many documents I've got in it. I can see the fields. I can see the attributes. And what's really, really important is I've got a search explorer which helps me search for something. So, for example, if I search here for rock, I've get back results. I've get an example of the REST request I would have to do in order to get those results back. And what's really interesting is, where is it? Oh, okay, that's really interesting. Probably due to the screen size, I cannot see that button. There is a button here in that screen that allows you to create samples of any language that you would like to use in order to call that search API method and get those results back. I will show it to anyone after this speech. When I disconnect my laptop, the screen resolution will be adequate to show that button. So we've created an index, we've uploaded data. We can also search for the data from here, although we've seen it through the portal. The URL is similar, trails/docs, and I specify the search parameters as a query string argument, and voila, I'm getting the results back for that search service. Okay, I've created the search, but I haven't really implemented all those cool features that we've talked about, right? So, step 2, let me go back to my slides for a moment. Search. So, how do we enable all these features? What does Azure Search supports? So we have searching for text, we have highlighting, we have filtering to narrow down the search results that we want. We have sorting, paging, we have projection, counts, lookups. Lookups is getting data by their key. And a really, really nice feature that I particularly like is more like this. So let's see. Another useful feature that we've talked about is the facets that allows us to return a smaller number of documents based on matching criteria selected from our left column, and provide aggregate data based on that search query arguments that we provide. Of course, we can support facet counts for various values of specific fields, and the field used for facet calculation might be set during the index creation. So if I go back to my portal that we've seen earlier, here, let's close this one and this one. And if I scroll down here, you can see the attributes of the fields that I've created. And if I click on this one, I can see which attributes have been set for this field. So the facetable attribute has to be set on the index creation in order to be able to use it on the code later on. So, of course, you can return multiple facets in one request. It's a list that you are providing on search. And let's move on. I'll skip this one. Of course, we can have suggestions for autocomplete. This allows developers to provide a type-ahead experience for the users, so they can select more precisely the search terms that they want to use. That supports infix matching for suggestions. This means that even if you made a spelling mistake, it will still search for the correct term. It optionally provides fuzzy matching to enable more flexibility and supports up to 100 suggestions per result. No limit on the length of the fields or the minimum length of characters used. You can even start searching from the first character that the user pressed. Okay, I'm going to be really fast now. And lastly, we can enable geospatial search, and we can search results by distance or by intersection. So we can enable rich user experiences like get me the results that are closer to me right now or inside a polygon or something like that. Okay, let's go to the demo of searching. I haven't created, sorry, it's open. Come on. Okay, I have it open here. So the first thing, now we've seen how to create an index using REST APIs. I've created a small program here that I'm going to run. And what this program does is that creates an index from a data set called USGS. It's with data from the US Geo service. Has a lot of cities and locations and stuff like that in that data set. And I'm currently using that to create an index. So I've just created an index and synchronized 6,696 documents in my index. That was done using the .NET SDK, which is a wrapper of the REST framework that we've seen earlier, to make it easier for developers to create indexes and search the Azure Search Service. Now I have an MVC application that has a controller, and in order to make it faster, I'm going to open a complete solution. Okay. This is the same solution that we've seen earlier, only that it has all the features that we talked about. Come on, set a start project. We need to go to the web config part and we need to specify the name of the service, not in capital. And we need the password, which is the API key that we've talked about earlier. I'm going to go back here and grab it. Copied. Okay, save and run, and let's hope that it works. It's building. Okay. Cross my fingers. Yes, it loaded. So now I can search. And I'm getting a null reference exception. I've probably Yeah, I'll have to see that during the break. I don't want to waste any time on it. But if it was run, all we would see is the search results with the facets on the left and the results of the cities that I've searched for. And that's all created from this code here. So all I have to do is specify a set of search parameters. I want to search for all data. I could filter those data if I wanted. I want these fields to be returned to cut down the number of data that is returned. I want to include a total count number in order to show that. I want to highlight the fields in the description field and put a bold tag before the hit highlighting. And then I want to create facets on those fields, the country name and the elevation, and I can specify the interval of the facets, or if it was date, I could specify the range of dates. And once I've created all these search parameters, I could then call search. That's all I have to do, using the search text that the user provided, and get a bunch of JSON documents back that's the results from that query. It's really pretty straightforward. That's all I had to do in order to search my service using all those features that we've seen before. So let me go on a bit and talk about analyzers and multilingual support. So what's an analyzer? As we've created our index, we didn't specify any analyzer, so it's using the standard analyzer that searches for the words that are contained in that sentence, right? So all the words are broken, and the search service searches for those words from the user input. So the problem with that is that we don't have accurate results like we would have with an English analyzer. The English analyzer would stem the words, so it would cut the words to their stems and cross over, delete any stop words like to, a, of, common words that we're really not interested about. So Azure Search uses Lucene, because it's based on Elasticsearch. So no surprise there. It's built on Elasticsearch. So it uses Lucene, but we didn't like that too much because we've actually invested a lot in natural language processing. We've been using it in various services like Bing, Office, and SharePoint. And this natural language processing allows us to support more than 50 languages that are supported by the Lucene analyzers. And we have morphological analysis on the words and spelling variations and entity recognition. That's really, really useful. So what's the difference from an English analyzer? As you can see in the previous slide, the tumble was cut off and didn't contain the E at the end. So if someone searched for tumble, the actual verb, it wouldn't find it. Or the think, which was thought, if you remember, and wasn't changed. You see, it wasn't changed by the English analyzer because it didn't know where that word came from. Using our natural language analyzer, we can find the correct verb and change that and actually find more results. So this is the difference of stemming versus lemmatization. You see the words in red, the differences between them. And finally, tuning. Azure Search allows us to rank and tune our results and put weights and scores into our fields, which allows us to put more relevance and boost search results that we're really interested in top and put other documents lower at the end of the search results. So we have scoring profiles, which allows us to rank the search results. We can use weight and fields. We can use freshness of the data to score our results. So new entries on our index will come first, and older entries on our index will come later on. We can have a magnitude profile, allows us to put magnitudes if the value of this document is in that range, put it on top, or if it's not, put it lower, or distance, or even tag, which is very, very, very useful and can affect scoring of the search results. So that's it. I haven't had the time to give out those chargers. So the first one that has a question will get one. So please have a question. And you can have the rest one by coming here. Thank you very much, and hope you liked it.
Because we are running, do you hear me? Because we are running out of time, we will get only one question, and then you can find Costas in private. Sorry, ladies first.
So you got one, right?
Yeah.
Before, so another one will get.
Okay.
Yeah. I would like to ask, does Lucene Search, Azure Search allow weighted queries, for example, in a query, if it has two terms, for the one term being more important than the other?
Yeah, you can put weights on that search and differentiate on the same document, put weights on different fields of the same document and affect the ordering of the search results, yes.
Mostly I meant like the user putting weights on the query, not the documents having more important fields.
Yeah, you mean by searching?
Yeah, I mean, for example, if you have strawberry fields, like strawberry being more important in the query search.
I'm not sure I've got the question, but if you've seen the first slides that I've shown, there was a drop box that said order by pricing or order by, I don't remember the second term or what was it. That drop box actually affected the weight of the importance of a particular field on my index. So that's why I would see different ordering on the results of the search term. If not, that's not the question that you asked, please find me on the break and I'll
Thank
answer.
you.
Thank you very much.